A radar image from Venus forced planetary scientists into an impossible position. They were staring at mountain peaks glowing bright white as if covered in fresh snow, on a planet hot enough to melt lead. And once that image arrived, one of the safest assumptions in planetary science stopped being reliable. In the early 1990s, NASA sent back something deeply wrong from Venus. The spacecraft called Magellan had begun mapping the planet using radar, cutting through the thick sulfuric clouds that permanently hide the surface. Across the volcanic plains, the readings behaved exactly as expected. Dark terrain reflected weakly. Rougher regions scattered the signal. Nothing unusual. Then, Maxwell Montes appeared. Venus's highest mountain range suddenly lit up like a frozen mountain chain on Earth. Radar reflections came back intensely bright, not scattered randomly, not distributed evenly. The highest elevations were glowing with extreme reflectivity, producing brilliant white contours against the dark volcanic lowlands below. That image created a problem immediately. Because on Venus, snow cannot exist. Ice cannot exist. Water vapor cannot survive long enough to freeze. Surface temperatures sit around 860 degrees Fahrenheit. The pressure is crushing enough to flatten submarines. And yet somehow, the highest mountains on the hottest planet in the solar system were behaving exactly like frozen alpine peaks. The mountain itself had not changed. But the meaning of what scientists were seeing had become dangerous. At first, the safest explanation seemed technical. Radar reflections often exaggerate rough terrain. Maybe Maxwell Montes simply had a different surface texture. Jagged volcanic rock can bounce signals directly back toward orbiting instruments, creating unusually bright returns. That explanation worked for a while, until researchers compared elevation maps. The strange white reflections were not scattered across random rough terrain. They formed distinct boundaries. Everything above a certain altitude became dramatically brighter. Everything below remained dark. The same mountain. The same rock. But the radar brightness obeyed altitude with impossible precision. And suddenly, the image changed meaning. This was no longer a measurement problem. Something in Venus's atmosphere was interacting with the mountain peaks themselves. Now the observation became much worse. On Earth, altitude changes temperature gradually. Climb high enough, moisture condenses. Clouds form. Snow begins accumulating. But Venus has no water cycle remotely capable of doing that. Its atmosphere is 96% carbon dioxide, wrapped in dense sulfuric acid clouds suspended miles above the surface. Nothing in known planetary weather should create frost. Yet Maxwell Montes kept returning the same impossible image. Bright white peaks glowing unnaturally against a world built like a pressure cooker. And that forced scientists into a dangerous reinterpretation. Maybe the white material was not ice. Maybe weather itself was being misunderstood. Researchers started examining the chemistry of Venus's lower atmosphere. Near the surface, temperatures rise high enough to vaporize materials that remain solid on Earth. Metals normally locked inside rock can enter the atmosphere as gas. Sulfur compounds circulate continuously through volcanic activity. Under ordinary planetary assumptions, none of this mattered. But Maxwell Montes was not ordinary. At higher elevations, temperatures drop by nearly 200 degrees Fahrenheit. Still unimaginably hot. But suddenly cool enough for something unexpected to happen. The same bright white peaks now gained a terrifying new interpretation. They were not reflecting frozen water. They were becoming chemical condensation zones, like clouds forming over mountains on Earth. Except on Venus, the vapor was metal. That realization expanded the entire problem. Because now scientists understood they were watching weather happen on Venus. Not Earth-like weather, not familiar atmospheric circulation. Actual precipitation. Except instead of water vapor cooling into ice crystals, vaporized metallic compounds were condensing directly onto the mountainsides. The image had changed again. Those bright white radar contours on Maxwell Montes were no longer strange reflections. They were deposits. Venus was coating its mountain peaks in frost. But not frozen water. Heavy metal frost. The leading candidates quickly emerged. Compounds like lead sulfide and bismuth sulfide can vaporize in Venus's infernal lower atmosphere. As rising gases drift upward toward colder elevations, those compounds begin condensing onto exposed rock surfaces. The process behaves almost identically to snowfall. Evaporation. Transport. Cooling. Deposition. Same weather cycle. Completely alien chemistry. And suddenly, Maxwell Montes became something far more important than a strange radar anomaly. Because every planetary climate model built around Earth assumptions had just become weaker. For decades, scientists treated weather as fundamentally tied to water. Rain required water vapor. Snow required freezing temperatures. Ice required stable chemistry built around hydrogen and oxygen. Venus shattered that framework. The brilliant white peaks glowing against dark volcanic plains were proving something much larger. Weather is not about water. Weather is about phase change. Anywhere temperature shifts across an atmosphere carrying suspended compounds, precipitation can happen. Even on a planet hot enough to melt lead. Which means planets orbiting distant stars may be producing weather systems humans barely understand. Iron rain. Silicate clouds. Metal snowfall. The opening image never changed. Those bright white peaks were always there. What changed was what they meant. Venus does not have snow. It has something far stranger. Hell can have winter,